Good morning, everyone. Welcome to part 2. So we did all this in part 1, and now we're gonna move on to this stuff. So this goes like way back to like the beginning of the year, but we had that equation a m to the n is equal to n square root of a to the m. So keeping that in mind, that will help us solve for these equations. So before we start, I'm gonna move 8 to the right side, or not to the right side. I'm gonna move 1 to this side, so it'll be 9, and then rewrite. So we have this. Now let's apply this thingy, and we'll have 3 on the outside to the power, m minus 27 to the power of 2 on the inside equals 9. So to get rid of our square root, we're solving for m right now. We're gonna need to raise each side to the power of 3. That leaves us with m minus 27 square equals 9 to the power of 3 is 729. And now we're going to square root both sides to get rid of this thingy. And we're going to have m minus 27 equals, the square root of 729 is, what? The square root of 27. So we have 27. And another thing, the square root principle says that, hold on, wait. It says that it's like plus or minus over here. When you square both sides of an equation, you have plus or minus. So this is actually plus or minus 27. And so what that means is m minus 27 equals 27 or. We haven't tested yet, so we're not sure yet, but it would be like this. And then m is going to equal 0 here. Oh, no. M is going to equal 54 here, and then m is going to equal 0 here. And I tested it beforehand already, and they both work. So I know that these are the solutions, but if you wanted to test it, then all you have to do is take this, plug it into here, and then solve the equation. If it comes out to be like something false, like 9 equals 5, 9 equals 4, 5 equals 8, something like that, then it's not a solution. Yeah. Okay, so for the next one, same thing. It's gonna be, I'm gonna move 9 to the other side. So we're gonna have x to the power 14 equals 3. I just added 9 to both sides. Negative 6 plus minus negative 6 plus 9 is 3. So, and same thing, we have 4x to the power 1, which is just x. So I'm gonna leave it like that. Now we're gonna raise both sides to the power 4, and we're gonna have x equals 81. And that is our solution for this. Okay, so next we have what are these called? Solving radical equations, I believe. And so what I'm gonna do first to solve is I'm gonna move r to the left side. So I have 4 plus r equals square root of 4r plus 61. And we're gonna want to square both sides to get rid of the square root over here. And there's a formula, a squared plus 2ab plus b squared if it's plus, and if the inside is negative, then I believe it's a squared minus 2ab plus b squared. So this is our a, this is our b, so a squared, so 4 squared is 16, and then we have plus 2ab, which 4 times r is 4r, 2 times 4r is 8r, and then we have r squared, and over here we get rid of our square root thingy, and we have this, and so minus, let's combine like terms, so I'm gonna rewrite really quick. So r squared, and then minus 4 on both sides, minus 4r on both sides, so we have plus 4r, and then minus 61 on both sides. I think that'll give us 45. So we have minus 45. Okay, so this is our rewritten equation. R squared equals 4r minus 45 equals 0. And we can factor this out. It would be, think about factors of 45. 9 and 5. And which one has to be negative in order to satisfy this? 5. Because 9 minus 5 is 4, and 9 times negative 5 is negative 45. So we have r minus 5, r plus 9 equals 0. So we have r equals 5, r equals negative 9, and we need to check for extraneous solutions. So to do that, we're basically going to plug in these values back into our equation. So let's plug in 5 first. So we have 4 equals minus 5 plus 4 times 5 plus 6. 4 times 5 is 20. Oh, plus 61. 20 plus 61 is 81. Square root of 81 is 9. And we have 4 equals 4, and that is true. So we know 5 is a solution. And let's test 9 now, negative 9. So we have 4 equals 9 plus square root of 4, negative 9 plus 61. 4 times negative 9 is negative 36 plus 61. You have 25. Square root of 25 is 5. So 4 equals 9 plus 5. That's false. So this is not a solution. Our only solution is 5. Yeah. That's how you do that. This one is like the same thing. So let's do it. Let's move, I'm gonna move 1 to the right, or 1 to the left. I'm gonna move it over here, and I'm gonna move this over here, just to make things simple and that, so that's positive. So now we have 5r, wait, hold on. Let me not skip steps. So we have 5r plus 1 equals, oh, actually never mind. Okay, JK, I'm going to move this to here and leave 1 there. Where was I? Okay, now raise both sides to the power of 2. That gets rid of our square root, and over here we have, following the same formula, a squared plus 2ab plus b squared. And that's gonna give us a squared, so this is gonna be, oh, let me rewrite this so it's a little more clear. So square root of r plus 1 minus 1. Okay, so I'm just rewriting this part to be that, so it's a little more clear for when we use our formula. Okay, so when the inside is negative, the formula is a squared minus 2ab plus b squared. So squaring the first one gets rid of that, and then 2ab, so minus 1 times this makes it minus, and 2 of that makes it minus 2. Square root of 8r plus 1, and it's gonna be 1 plus 1, because minus 1 square is plus 1. Nice. Okay, we're gonna combine. We'll see what we can simplify first. Combine like terms and continue. So we can get rid of plus 1, and then I'm gonna move 5r to the right, and then this to the left. So I'm gonna move it to the left, which changes the sign. Move 5r to the right. 8r minus 5r is 3r plus 1. And I'm gonna square both sides, and that's gonna give us, so when you square, it's squaring these both, so 2 square is 4, and it's gonna get rid of our square root thing, and over here it's gonna be 9r squared plus 6r plus 1, and let's multiply this in. 32r plus 4 equals same thing, and then combine like terms. I'm gonna move move 9r squared to the left now, because I want to be able to set it to 0, so I'm gonna move everything to the left. 32 minus 6 is 26. 4 minus 1 is 3. Set it equal to 0. And now we're gonna want to factor this out, so let's see. I'm just gonna make 9r positive. Okay, what I did is broke up 26r to become r minus 27r, and then I factored out r from these first two terms, factor out 3 from these next two terms so that the inside would match. So you see that it's 9r plus 1, and then you can write those both as 1, and then r minus 3 becomes the second thing and equal to 0. So then I wrote this whole thing equal to 0, and I got r equals that, and set this equal to 0 and got r equals that. So next you have to test, and I also tested beforehand and this doesn't work, so we just have now 3 as a solution. 3 does indeed work. Okay, next we have graphing radical functions. So what I do for this is I apply the transformations, which we have plus 1, so it's going to be the opposite. It's gonna, here's our origin, we're gonna move left 1, we're gonna be here, and we're gonna move down 5. So 1, 2, 3, 4, 5, we're gonna be here, and that is our new origin. And then I make a little table, and I'm using square root of x because I'm just ignoring all the transformation that we have already applied. So we're just left with this, and we're gonna plug in values to find values to graph values. So if we put 0 in there, it's gonna be 0. If we put 1 in there, it's gonna be 1. 4, so what I'm doing is plugging in the thing into finding the square root of x, which are these values, and that's how I'm getting these things over here. So square root of 4 is 2, and then square root of 9 is 3. And now these are not coordinates, these are describing where to plot my point. So 0, 0 is just here, and we have 1, 1. So that means go to the right 1, go to up 1, and then we have 4, 2, which means go to the right 4 times, 1, 2, 3, 4, go up 2, 1, 2. And then 9, 3, so 9 to the right, up 3. And then you're just gonna graph this like that. Okay, next. Oh, another thing to note. Actually, we'll do that after. So we have to the left 5, which has us here, here. And then let's make our table. It's gonna be cube root now. So you have 0, 0, 1, 1, 8. Cube root of 8 is 2. Cube root of 27, 3. We don't get to 27, but just write it anyways. So 0, 0 is just here. 1, 1. And then 8, 2. And then that's that. And you want to reflect this to the other side of the graph, because this is only a half of it. This is only half of it. You need the other half. Like that. And what I did is just did the opposite. Down 1, left 1. Instead of right 1, up 1. Oh, I meant down 1, left 1. Yeah, so it's like when it's a cube root, or like to the 5 or 7, 9 root of x plus or minus whatever transformation, your graph is going to continue in both directions. What if it's even? If it's, I forgot what this number is called, but if it's the square root, or like 4 or 6 or whatever, the domain is contained, so the graph only continues to one side, and that's why I don't have arrows over here. Yeah. Okay, let's do these ones, because we'll do these two, and then I shall make another part. So simplifying is simple. You just need to find a way to factor out the inside number into something that will allow you to take something out. So something that has a square root, an even square root, which in this case 25 times 3, and you can take 25 out, or not 25, you can take 5 out, because square root of 25 is 5, and then 3 is left on the inside, and you have to multiply these two numbers, and that makes 40 square root of 3. So that's the answer for this one. No, or not the answer, that's the simplified version of that value. So over here we have 2 square root of 9 times 7, we can take 3 out because square root of 9 is 3. So you have 2 times 3, square root of 7. So you have 6, square root of 7 is our answer. And that's that. Next video we'll go over this page and then I'll make one more on trig. See you soon.